Hello everybody, it's Crazy Logics 007 on YouTube, Crazy Logics in the forum, and everybody else just calls me Damon. So follow up to the live stream, we were working on this Audiopipe 1500. We had determined that we weren't getting any pulses and we weren't getting a correct amount of power to the TL494 chip to produce those pulses. Now we've already removed all the FETs and all the pull down resistors and all the gate resistors. Everything had got fried. And I said, well, I'll have to draw out the remote turn on circuit. We were looking at it and it wasn't getting power to this chip. Well, some of the guys in the forums, some of the groups, on Facebook said, hey, somebody did post some sort of schematics for some of the audio pipes. And so we do have a partial schematic. Some of the schematics in this are absolutely terrible. They're so fuzzy you can't hardly see, you can't read what these designations are. But here is the remote turn on circuit, and you can see it says that you get 12 volt in. Here you got remote over here, and you got your grounds down here, and then you have an output right here to what they call the 7500. The 7500 chip is the same as a TL494. So slight variation. This is maybe not exact same revision. But let's talk about the remote circuit real quick. The remote power comes in and it actually goes through this little these two resistors down to ground, and this is a voltage divider. And so that allows us, you use the correct values of the resistors to tune what kind of voltage you want to see here. And this capacitor is here for some stability to turn this NPN transistor on. So positive voltage comes in, it's voltage divide, that we got a stable power here to turn this transistor on. Well, when this transistor turns on, it completes a path to ground. And that path to ground through these two resistors turn on these two. And this one's actually paired. A lot of amps will not have this second one. They'll have just a bigger transistor. They've used small surface mounts. These are PNPs. And so the way I always tell is the arrow always points towards the negative. So this would be NPN, because you got a negative here in the middle on the base. So this is going to be a PNP. But it turns on a pair of them through these two resistors to immediately pull these on. So that takes this 12 volt. When these transistors are turned on, they'll pass 12 volts through. And you notice they join at a little dot right here, which is the same little dot that goes out to power the chip. So if we take our multimeter on voltage here, let's turn this where I can get to it. You can see up in the corner I have my power supply on, and we're gonna turn on the remote. But those numbers happen to be exactly right in that schematic. They actually happen to be the correct stuff. So we can actually place our probe on ground, and we can measure and see if we're getting voltage here. Yep, we are. We're going to go to the next place, which is the base of Q20. So Q20 was right here, and so this is the base. And so we're getting 0.7, and it needs at least 0.6 to turn on. And so that should be giving us an output. Oh, that should, we should have 1.96 here on the top. This would be on the collector of Q20. And when we turn it, when we hit the remote, I'm going to hit it right now, it should go down to ground because that transistor's turned on and pulling to ground. So that should be pulling on the base of both Q17 and 18, which is right here. So with nothing turned on, we see 1.96. 1.96, that should be getting pulled down. It is. So then let's see up here on the emitters, we have full voltage, and so they should pass voltage up to their collector when turned on. And we're not getting anything. So one of a couple things is wrong. Either those two transistors died, or the chip has died, or something is pulling the chip down so hard that when these transistors turn on, it's getting pulled down. So here is what I'm going to try to zoom out and explain. Alright, get my little pointer out here. So this chip out of legs 9 and 10 run a set of transistors here and here, and a set of transistors here and here, and those are the ones that provide the power to the two different banks, here and here, and then back here and back over here, for the outputs. And anytime you have damage like we had up here where the gate resistors and stuff totally fried and stuff, it normally comes back and at least wipes out the PNP transistors on one of these pull-up, pull-downs. Now, I have a video where I draw all of the schematic out, and I tell you how to, when you have these out, how you can meter from positive and negative to ground, and figure out which is the PNP and which is the NPN. Now, I'm going to show you, I got part of the schematic here, and this is the one that is just fuzzy as heck. See how you can't hardly read? That's like Q32 and Q something, which is actually for this board it's Q33, but you can barely read them. But you can see the 10K pull down resistors. We had those we had to replace. These are all the resistors that are running to the FETs for turning on. And you've got two different transistors for each bank, and you're going to have two banks per transformer. I don't know what these are because I can't read that, but we know that it's this little group, that little group, and that little group. I traced it with the multimeter a little bit, and so doing that, I also kind of drew it. I just drew a little schematic layout of it here, where the 494 is. That's a cap. That's sorry, that cap right there, and then these would be the transistors right by it. So all in order. So I kind of draw this stuff, and I got this one. I got these transistors, and these are the 1K resistors. And those 1K resistors are these that are leading in, and they come in from pin 9 and 10 from the TL494 through 1K transistors right there, or resistors right there. And so I've laid them all out, and then I looked at the marking on the transistor, and it was an L6, an M6, L6, M6, L6, M6, L6, M6. So you can see that. So I figured those out, and then based on what I could barely see on the schematic, and then using the same method I did in my one video where we go over all the power supply, how a switching power supply setup works and how you determine those. If I somehow figure out how to do it well, I'll try to link that video at the end of this one, or I'll put it down in the comments if I, worst case scenario. But figured out that M6 is the PNP, L6 is the NPN. So I'm going to replace these all. I'm just going to do it all. And anytime I get any of these that get damaged, I just say screw it and replace them all. Since these are little bitty tiny SOT23 package, I'm going to replace them with the MMBT3906 for the PNP, and the MMBT3904 for the NPN. And so let me get that up there so you can see it. And those are the package that I use to replace anything that's this STO3 size in a power supply setup. They always work really good. They turn on and off well. They're standard issue in tons and tons of amps. So I'm going to show you what I do to get all these out. Since I since I drew a little map and I know which ones are which, and I'll know which ones to place back in the right spot, I'm just going to take them all out at one time. That's the whole reason for drawing that out. But what I do is I get a little flux. We're going to smear a little flux goo on all these. And I'm going to add leaded solder to all of them. Just rub it on each of the 3 legs and kind of blend it in with the lead-free solder. And then I'm going to get my hot air rework station and just remove them instead of trying to get them all out. And so I'm just getting some leaded solder, and what that is doing when I'm mixing that with the lead-free solder is lowering the melting point. And the reason why you want to lower the melting point is so that you don't blow off all the other components that are here. Now, when I was probing, I did notice that the PNP transistors were shorted. While I was making sure I knew which transistor was what. But now we've just got all those nice and their temperature lowered. My poor old hot air rework station is about shot. I've got a new one. I just have not got it put onto my bench. So I'm getting there. So now we can come in and let me see if I can zoom in here for you. Just in a spot that makes it a little bit doable. And so now these should melt before all these other components, just a tiny bit, and allow me to pluck them all off without having to worry about blowing away the other components. And you can get the whole area warmed up in general. You just start plucking them off. And that plenty of flux there is going to help to keep everything nice and cleaned up. Oh, I dropped it. I'll have to grab it here in a second. Dropped that one. There, we don't even care about those. I have to get in here where it's tight. Be careful not to blow that capacitor. I'm going to lean it over if it'll lean. Nope, I really won't. So I'm just going to get some general heat in this area. Be careful of the speaker wire, or the power wire, sorry. My head may get in the way here so I can see what I'm doing. Alright, all those off. So now we're going to let the board cool down. And we will get, I'll zoom out just a little here. Rubbing alcohol. I'm going to clean up some of that flux. And so our drive transistors are all out. Let's see if we get power to this TL494. Now, it may still be dead. It may have, since we had these transistors short, it may have taken out the TL494. We may have to remove it. Alright. But now we can bring this back over here. And if you remember from the live stream, we got this in here at voltage. Everything's kind of a mess on my bench right now. Trying to keep things out of the shot. So we're down here on, you'll see that meter. Excuse me. Broccoli cheddar soup burp. So we wasn't getting no power. If you remember in the live stream, I had my little cheat sheet card here and stuff, and so it says VCC is pin 12. So it starts, we got to put our black probe on ground. So it's 9, 10, 11, 12. Our meter's showing maybe 2 volts here. And we're not getting anything. Still not getting anything. Should be getting 12 volts and we're not. So I think it's taking that chip out. So to remove it, we're going to go do the same thing. We're going to add a little flux to the chip. And we're going to drop the temperature of all those joints by adding a bunch of solder along them. Mixing in this leaded solder with that lead-free solder. Make it where we can get this chip out. Without blowing all the rest of the components away. Go back to the hot air and get our tweezer. I'm going to start warming up this general area, and I'm trying to blow away from the electrolytic capacitors here. Almost there. There we go. There to pop up and off there. So now we can bring our power back up. We're still going to be looking at ground and pin 10, so, or 12, 9, 10, 11, 12. We hit the remote, and what do we get? 1.8. So we still have a problem. So that chip may be good. That's why I just said it right there. So we should be seeing above. I want to look at this schematic here and call out the numbers for you guys. We should be seeing on Q17 and 18, which are these two right here. We got our 13.5 volts, which matches our power supply. They're letting out about 4, and when we hit the button, they are not putting out what they're supposed to. They're changing, but we're not getting it. So I'm thinking those two are leaking. To you that, or we've got an internal board short. So their base, let's make sure their base was getting grounded, because those are PNPs. So this is what the base reads with no power on it. Then it gets pulled down, and so that should be way sufficient to turn that on. Both those. So I think those two need to be replaced. This chip may be good. So we know those are PNPs. And so we're just going to go ahead and replace them with the MMB BT3906s. Those will work. Same procedure. I'm going to keep this chip right here. Oh, I forgot to turn the power off. There we go. Don't forget to turn power off. Get a little bit of flux on there. And I'm going to remove these. I'm going to replace those two only, and so we can test that circuit to see if it gets there. And then I'll bring you back here. Because this is going to get long. This video will get too long if I don't. So I will be right back. Okay, we're back. I've soldered in the two new PNP transistors on the turn-on circuit. And so we're going to go on ahead and see. We're going to go back to pin 12, 9, 10, 11, 12. Oh, I got to turn on the power. Oh, I'm knocking stuff off here. And we're going to put that on the ground right now. And we hit the remote. And looky there, 13.51. Shazam. So I got two options here. I can try to reuse this chip. This chip may be good. This chip also could have been part of the problem. And so I may just replace it with a new one if I have one. Let me see. I have two, it looks like. So I think because this thing's already seen damage on the input side and on the output side, it goes right there in the trash. And I got a brand new one here. I'm going to have to order a few more of these. We're going to go ahead and get a little flux. Like I said, that chip might have survived. We already have solder down there that we've already mixed up with lead. So I'm just going to give this a general heating. You can see it slipped a little when the flux got melted. That's a good techie flux. It's Advantech, or not Advantech, Amtech, sorry. So now we're starting to flow in. I'm just going to flow right back in here. Give it a little nudge to make sure it gets all centered up. Round and round on it a little there. That should get it. Now I'm going to take my magnifier here. I don't have any pins that are bridged, so that's good. So we're going to go back to pin 12. See the voltage there. It comes up. That's beauty. So let's go to the scope. Scope's going to be right here. Let's see if we can see anything on these pads now. Oh, no, sorry. It's just going to be the outputs of the pins because we have all the transistors out. And there we go. We have a square wave on pin 9, a square wave on pin 10. Shazam! The drive is working. Turn everything off here except for my hot air. So that means I can replace the drive transistors on both sides, put all new resistors in. I'll probably bring you back for that real quick to show the drive, and then I'll be putting it in. This might be the end of it because we've talked about that. Now it's just a simple matter of doing this. Something else interesting happens because on this amp, if you watch the live stream, the output section did not show any shorts, so it may be just fine. So this may just be a matter of putting those back in, replacing the resistors that we took out and talked about in the live stream, and then putting in new 3205 FETs, and this thing will power up, and this amp should be good. So like I said, I'll bring you back if anything else crazy happens. Otherwise, this is just standard stuff that's in my other videos. As a matter of fact, I see if I can pull up now that video where we did all the stuff about power supply repair. Was it the SAE? Was it the Sundown that we drew it all out in? Yeah. Yeah, it was. So let me switch over here to the left side. So this is the video, the Sundown SAE 1000 mono amp repair part 2. I don't know if I've published the finish for this. I think I got everything up and running. I don't think that amp's around here anymore. So I may have. I'm still a little under the weather, but this is the video. You'll see in here we are drawing out how the drive circuit works, and here's a TL4494. So if you need more about this video, then or about how these little drive circuits work, just watch the Sundown video. I'm not going to repeat myself 100 times here, so that way we can get down to the dirty on specifics on amps. I'm going to try to get some more specific stuff, because I'm with a bunch of people out there that have said, man, it's kind of hard to have to jump around between 20 different videos. It's really nice to see the title, get specifics on that, and then know about the other stuff. So let you know about how the rest of that is rebuilt. In almost all my early videos, we talk about replacing power supply FETs and stuff. So if you need more info on that, check out a few of those videos. No shorts apparently in here. So this video will end here. As long as all that just is sticking in new components, and as long as the output section was not the problem. Well, you guys didn't think I would let you off there without listening to it. So we go power on. Here it comes up. Turn the volume up here. Still got to cook it in, but it's all done. It does draw a lot of current on startup, more than my little supply will like. It likes the bigger supply much better. It has some lower value discharge resistors on the rails, so it does take a bit of inrush there to get them things charged, and that's it. Thanks for watching.